Hello, my name is Itamar Frankenthal. I'm an electrical engineer and the owner and CEO of Rose Batteries. In today's recording, we're going to walk you through the basics of a high quality, high safety battery pack and demonstrate some of the features that differentiate high quality battery packs from cheaper and perhaps less safe alternatives. What we're going to be going through is what's called a 1S 1P or 1 series 1 parallel, alternatively a single cell battery pack. And we're going to show you all the components that it takes to make a battery pack safe and show you some of the assembly nuances that demonstrate high quality in manufacturing. We will start with component number 1, which is the cell in and of itself. That's what you see over here. In this drawing, we're showing a moly cell, a 103450. It's called that because it's 10 millimeters wide, 34 millimeters long, and 50 millimeters wide. And it's a very popular prismatic cell. In this case, it's a 103450 DA. The first component for building a safe battery is to use safe cells. Cells are the underlying lithium-ion battery before they are assembled. Choosing safe cells ensures the safety of your product. In this case with moly, part of what you're getting is a very high reputable brand for the cell, and the cell has in it a CID or current interrupter device, which means that if there's a high current or a short circuit, the cell has an internal fuse that can disconnect and ensure the safety of the design. As you'll see in this recording, a high quality and high safety battery would typically have 3 levels of safety. The first is starting with the cell in and of itself having a CID. The next component that goes into the battery pack is over here, item number 2, and that is a PTC or positive thermal coefficient. It's also a form of a fuse. When the device gets hot or the PTC gets hot, there's 2 sheets of metal that are going to separate and effectively disconnect like a fuse. What makes PTCs unique is that they are resettable, and therefore in the event that you have a short circuit and then you're able to address the issue, the PTC will reset itself and enable you to continue using the battery pack. However, PTCs, after they have once been used, do have much higher impedance and therefore can affect long-term performance of the battery pack. As we continue going through the bill of material, we get to item number 3, which is the safety board. The safety board, at a minimum, will provide 3 levels of protection: over voltage, under voltage, and over current. Over voltage means that if you overcharge the battery, the safety circuit will disconnect and make sure that you can't put any more charge into the battery. A few years ago, many of the hoverboards were making headlines for exploding. What's interesting is that many of the fires took place while the hoverboards were plugged in and charging. When you're charging a battery, the chemistry is most volatile and most at risk. Because of the higher voltage, the chemical reactions could be accelerated because of the high potential. Therefore, having a protection board that prevents overvoltage or overcharging is essential to the safety of a battery and essential for passing the UN 38.3 certification. The next protection is under voltage. This makes sure that you don't overly discharge your battery. Some of us may have experienced that if you let your laptop run for too long and you plug it in to charge it, the laptop still does not turn on. It just happened to me last week. That is an under voltage situation. If batteries are taken to too low of a voltage, they can experience permanent damage to the battery that can ultimately cause fires and safety hazard. Therefore, the under voltage board makes sure that you don't take the voltage of the battery too low. And in the case of the laptop, when you've taken a battery too low and over discharged it, when you plug it in, sometimes it won't let you turn it on because it's trickle charging the battery before it can go to a full charge cycle. The third form of protection in the circuit board is over current, which is another way to say short circuit protection. This means that if there's a short circuit, the board will kick in and disconnect, and that happens typically through the MOSFETs on the board. The result of this is that your battery has 3 levels of protection. The cell in and of itself has the CID. Then you have the PTC, and then you have the board. And usually your board is the first line of protection. The cell and the PTC are backups in case the board fails. From a reaction time perspective, the board typically has a much faster reaction time because it's a semiconductor, a MOSFET, that is reacting. What results is that you have three levels of protection: the board, the PTC, and the CID. Typically, you would want your board to be your first line of defense, the first line of protection in the event of a short circuit. This is because the board has a MOSFET that reacts faster and because it is resettable. The PTC, as we discussed, may be resettable, but firstly, it takes temperature in order for it to kick in, so there could be a delay. And secondly, there will still be a permanent change to the impedance or resistance of the PTC. The CID in the cell should be your last form of defense because once a CID is popped, once it disconnects, it's like a filament in an incandescent light bulb that falls off. You can never turn it back on. Just like the bulb is permanently off, so too the cell, once the CID pops, will be permanently off and you will not be able to use it anymore. Continuing in reviewing of the battery pack, so we covered item number 3, which is the board. We then go to item number 4, which is a connector, and generally it is advisable for cells to ship with connectors and not in bare wires because that helps prevent short circuits. Item 4 are the pins that get connected to the end of the wires. The pins then go into a connector, item number 5. Items 6 and 7 are the wires, and it's important to use a UL rating that meets your current needs. Item 8 is a piece of Kapton tape that goes on the cell before you attach the board to the cell. This is one of the differentiators between high quality manufacturing. We've seen many low quality batteries where the board is connected directly to the shrink wrap of the cell. The reason we put a layer of insulation between the board and the cell is because the board contains both positive and negative charge and often has little protrusions of metal that over time can scratch through the shrink wrap of the cell and cause a short circuit. And because the short circuit is happening at the component level of the board may not be able to shut down the short circuit, and you could have a short-circuited battery that can catch fire. Therefore, a key component of safety for a battery pack is to have some level of insulation between your board and the underlying cell. And again, this differentiates high-quality manufacturing from low-quality manufacturing. With regard to the Kapton tape, we also have over here a layer of Kapton tape that goes over the board and the wires before we put a level of external insulation. Again, this is an extra level of safety to ensure that there is no short circuit at the board level. As we continue to item 9 is a piece of metal strip that goes from the battery to the board. And this metal strip gets welded to the battery and gets soldered to the board. It is a conductor. Item 10 is a piece of PVC insulation that goes around the nickel strip. This again differentiates high quality manufacturing. Adding insulation to your nickel strips also adds labor to the manufacturing. The reason we add the insulation to the nickel strip is because the nickel strip is a conductor going along the side of the can of the cell. We want to make sure that no conductor is making direct contact with the side of the cell, and therefore we add the level of insulation around the nickel strip. Item 11 is a piece of fish paper that goes over the board, and the reason we put fish paper on top of the Kapton tape is because the fish paper is puncture resistant. It is a form of vulcanized material, and it provides both electrical insulation and mechanical insulation to prevent puncture occurring to the battery pack, specifically in the area of the board. Again, this differentiates high quality manufacturing. Many low quality battery packs would simply use the shrink wrap of the battery to provide the level of insulation around the board. Item 12 is the shrink wrap that goes around the battery. The shrink wrap provides both electrical insulation and mechanical stability. Because it's shrunk, It makes sure that components don't move. And item 13 is an additional layer of shrink wrap that covers the battery in order to cover the top and the bottom of the battery pack. There's one other item that I'd like you to notice here, which is the wire routing over here. If you notice, the black and red wire go out at a 90-degree angle to the battery pack, rather than coming down the battery pack and out. The reason that the wires are routed this way is for safety to prevent short circuit. You never want your positive and negative electrodes or wires crossing one another at the board level. Said differently, if the black wire were to run down here, then the black wire would be covering the solder pad for the red wire. The negative would be covering the solder pad for the positive. Part of good design and safety is making sure that at the board level, your paths don't cross or don't have the opportunity to touch one another. We have seen some very high power battery packs where this rule is violated and creates an opportunity for a short circuit or for a safety incident. Therefore, it is recommended that whenever you do your wire routing, that the positive and negative should never cross one another at the board level. They may have to outside of the board. At the same time, it is best to avoid crossing at the board level. Hence, you see the wires here exiting to the left and then coming down rather than running over one another on the side of the battery. We hope you've gained a lot from watching this video. We hope you've learned about the essentials of designing a safe battery pack. Should you have a battery question or a need for design, we'd be happy to have one of our engineers speak to you. Just click the button below to fill out our Contact Us page. Thank you.